I'm a microbial ecologist and oceanographer. And one thing that I like to think about a lot are networks. And I see that from reading over some of the orientation materials, a lot of you also think about networks in the ocean, which makes a lot of sense. So you have simple processes and simple interactions, and when you have a lot of them, that you can have cognition emerging from that. Often people think when people working with networks, and when I've worked with networks in the past, I've looked at say, bivariate networks. So you've got two things. Well, one thing changes, another thing changes. And you can add memory into that process. We say there's some delay, right? A thing changes, and then something else changes 1 month later. But a kind of network that I've been thinking about recently are between trios of variables. So you can imagine you have two things that are related, and then there's a third thing that modulates that interaction. So you can imagine, let's say, like a neuron or a computational logic gate, say, with a very simple logical operation, say, and, right? So if you've got, A and B are true, then C is true. If either A or B are false, then C is false. One way you could look at that is you could say that B modulates the effect of A on C. So if B is false, no matter what A is, there's no effect that A is ever going to have on C. And if it is true, then A would have an effect on C. And we've developed a statistical tool to look for these sorts of 3 variable interactions in the ocean. And we can see that the oceans, at least with microbial networks, is just absolutely full of these sorts of interactions. And so I'm interested in looking at sort of the topography of networks between trios of variables with variables modulating each other. And that's true of microbial abundance, gene function, metabolic rates, and so on.